Okay, so we are going to cover section 1.2 and answer these questions here. So, for example 1, we got the length of each side of a square is increased by 3 centimeters. The perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. So, we're going to have an original square and we're going to have a new square. So the original square we're going to say is x by x, and then the new square, since the new square is each side of the original square increased by 3, it'll be x plus 3 by x plus 3. So just the original square increased by 3 units. Okay, so now we're going to use the perimeter of the new square. So we'll say perimeter of the new square is equal to 40 centimeters more than twice the length of each side of the original square. So 40 centimeters more than twice the length of the side of the original square. So our new square is x plus 3, x plus 3, x plus 3, x plus 3. So its perimeter would be 4 times x plus 3. So that'll equal 40 plus 2x. And from this point, now we just got to go through and we just have to solve the whole thing for x. So we'll distribute the 4. Get 4x plus 12 equals 40 plus 2x. I need to gather all the x's on the same side, so I'll subtract the 2x across. And this 12, I'll subtract it on over. So 4x take away 2x is 2x's. 40 take away 12 is 28. So we divide by 2, and we get x equals 14. Okay, we're asked to find the dimensions of the original square. Our units are centimeters, so we would say based on this, the original square is 14 centimeters by 14 centimeters. And that would be the dimensions of the original square there, since x was the length of one of the sides of the original square. They didn't ask us any information about the new square sides, so we're just going to skip over and not really say much about that. Okay, so that should be a method of wrapping this one up. Let's take a look and see what else they got in the section. Okay, so down here we got it looks like a distance equals rate times time one. Maria and Eduardo are traveling on a business conference. Trip takes 2 hours for Maria, should say for Maria, and takes 2.5 hours for Eduardo, because he lives 40 miles further away. Eduardo travels 5 miles per hour faster than Maria. Find their average rates. I made a lot of typos typing this in. Okay, so we're going to use a distance for Maria equals rate for Maria and time for Maria. And we're going to use a distance for Eduardo equals the rate for Eduardo times the time for Eduardo. So I'm using subscripts M to talk about Maria's information, and subscripts E to talk about Eduardo's information. So let's see here. 2 hours for Maria, 2.5 hours for Eduardo. So time for Maria is 2. Time for Eduardo is 2.5. So we currently have distance Maria is traveling is 2 times her rate of travel. And the distance Eduardo is traveling is 2.5 times Eduardo's rate of travel. Okay, how we're going to line the rest of this stuff up is Eduardo lives 40 miles further away. So that says if we take the distance Maria lives and we add an extra 40 miles to it, that will be the distance Eduardo lives. And now we can say, well, 2RM, pretend that's trying to make something like that. That's going to plug in for Maria's distance, and 2.5 RE is going to plug in for Eduardo's distance, because that's what Eduardo's distance equals, and this is what Maria's distance equals. And we have a problem here, because if I do that, Then I get RM here, and that equals RE there. So I need to plug in for something else before I totally substitute in. And here's the bit that I was missing. Eduardo travels 5 miles per hour faster than Maria. So since Eduardo travels 5 miles per hour faster than Maria, instead of using Eduardo's rate here, we could use Maria's rate plus the extra 5, and that would be Eduardo's rate. So Eduardo really is 2.5 times RM plus 5. Now that we're here, for DM we could replace that with 2 times RM plus 40 equals, in DE, instead of plugging it in here with the RE, because Eduardo's rate and Maria's rate are different, we use this statement here to plug in and get Eduardo's rate in terms of Maria's rate. And now we can use this value here, which is only in terms of Maria's rate as well. And we'll plug that in for DE over here. So we get 2.5 times RM plus 5. So I'm going to distribute 2.5. We get 2RM plus 40 is 2.5 RM plus, let's see, 2.5 times 5 is 12. 12.5, yeah. Okay, so now we just need to get all the RM terms on one side and everybody without an RM on the other. So this 2RM I'm going to subtract across. So that will be 0.5 RM. So 0.5 times Maria's rate. The 12.5 I'm going to subtract across. And 40 take away 12.5 is 27.5. To finish up, to get Maria's rate, we divide by 0.5. So dividing by 0.5 should be the same as multiplying by 2. And we get 55. Units were miles per hour. So we get 55 miles per hour is Maria's rate. And since we had Eduardo was traveling 5 miles per hour faster, this also implies that 60 miles per hour was the rate that Eduardo goes. So that's rate of Eduardo. So we have, we found their average rates. This is how fast each of them is traveling. Okay, let's see. So again, use subscripts to keep track of whose distance equals rate times time corresponds to whose. Okay, so example 3, we need a 20% solution of alcohol. So this chemist, she has 15% and 30%. So we'll say 15% and a 30, oops, not equals. 15% mixed with a 30%. And our goal is to equal a 20%. We're told we have 3 liters of the 30. We're not told how much of the 15 we have. If we have X liters of 15% and we mix to it the 3 liters of 30%, then we have a X plus 3 liters of 20% out here. So we got our setup here. So you're mixing 15%, you're mixing 30%. You're trying to get a 20%. So we'll say 0.15x plus 0.30 times 3 equals 0.20 times x plus 3. So what we're doing is we're finding the amount of pure, I guess it's alcohol in the system. It's not supposed to be a D in solution. Okay, so we got that 0.15x plus 0.3 times 3 equals 0.2 times x plus 3. We can multiply the whole equation by 100 to bump the decimal places 2 units over, which will make our numbers easier to think about. So I'm going to have us go through and do that real quick. Then we'll distribute and solve for x. So we got 15x plus 30 times 3 is 90. That's going to equal the 20 will distribute, so we'll get 20x plus 60. Need to gather all my x's together, so I'll subtract the 15x's from over here. I'm going to subtract them across, which will leave me 5x's. And then 60, I'm going to subtract the 60 on over, which will leave me 30. So we divide by 5. 30 divided by 5 is 6. So we get 6 liters equals x. So that's how many liters of the 15% we should mix with the 30. So 6 liters of, we'll just say 15%. Okay. So, we're going to look at a couple more from this section. Okay, so we have an artist sells a painting for $410,000. He invests a portion at 6 months at 2.65%. And then the rest is for a year at 2.91%. Broker tells them the two investments earn a total of $8,761. How much was invested at each rate? So we're going to use the I equals PRT equation for interest. So this says interest equals principal times rate times time. Okay, so what we're going to set up here is we're going to say the amount of interest from the first account. So we'll say interest from account 1 plus the interest from account 2 is going to equal the total amount of interest that we have. So we're going to say, we're going to call P the amount in the 6-month account. And then if we take the total amount of money we made, which is $410,000, and we remove the amount that we have invested in the 6-month account, that'll be the amount in the 1-year account. We take the total amount of money we made from selling the painting, we remove how much is tied up in the 6-month account, and that remaining amount's in the 1-year account. So the interest, we'll say interest 1 is the 6-month account, that's the, we'll call, and then interest 2 we'll say is the amount from the 1-year account. So interest 1 is going to be the principal in the 6-month account, which is, we're calling that P, times the rate. The rate of the 6-month account is 0.0265, times the time that we have it invested. Time is in years, so this is going to be times 0.5 because 6 months is half a year. Then for I2 account, we do the $410,000. That's the total amount we have to invest. We remove the amount that's tied up in the 6-month account. The rate of that one is 0.0291, and the time for this one is 1 year, and then that's going to equal the total amount of interest that we earn. And what this will do is this will be able to tell me, when I solve this out, this will tell me P, which is the amount in the 6-month account. So once I know how much is in the 6-month account, $410,000 minus that is in the 1-year account. So let me do some quick multiplications here. And we get 0.01 0.0132 5 times P, so these two multiplied together to make that, plus over on this side 0.0291 times 1, that doesn't really, times 1 doesn't do anything, so we're just going to distribute this. So we get 410,000 multiplied by 0.0291, which is 1193.1, minus 0.0291 times P equals 8761. So I'm going to subtract this one here that does not have a P on it. I'll subtract that across, and then these other two that have the P's attached to them, we're going to take their difference, so we get 0.01325. We subtract from it 0.0291, so that'll be negative 0.01585 P is equal to 8761 minus 11931, which is negative 3170. Now, since both sides are negative, I can divide them by -1 and both sides would be positive, and we get P equals this number divided by 0.01585. So let's see, 3170 divided by 0.01585 is $200,000. So this is the amount that was invested, we'll say, at 6 months. Sorry, they asked us for at what interest rate, so we're going to say that this was at the 2.65%. So we get that. Therefore, the rest of it that we're dealing with, which is if $200,000 is at 2.65%, then $410,000 minus this amount says the other $210,000 would be at, what is it, 2.91% for the other one? 2.91%. Okay. So we got the amount that's invested at each interest rate. All right, so for example 5, okay, a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters per second. The percent P of contaminants that are removed from the surrounding air can be modeled by the linear equation this. Okay. What flow to the nearest thousandth must a range hood have to remove half the contaminants from the air? So I think all we have to do for this one is we're trying to remove half the contaminants. Here's our equation where we have the percentage of contaminants removed here, and then this F value here is the air rate, or the airflow rate, I guess. So we're going to just say, all right, let's take that equation. Let's put 50%. I want 50% of the contaminants removed. So I'm just going to take this equation, and I'm going to replace the percentage with the percentage I want. And now that I have that percentage plugged in with the one I want, I can solve the resulting equation back to figure out the flow rate. So we'll subtract 7.16 or 18 from both sides. So it cancels there. We get 50 minus 7.18, which is 42.82. That equals 1.06 times the flow rate. So then we say, all right, let's divide the 1.06 across. So we get 42.82 divided by 1.06 gives us 40. We'll say 396 and just stop there. Is our flow rate. I need to figure out the units on this. What did the units they said? Liters per second. So we'll say liters, which is L per second. This is the flow rate that we're dealing with. And let's see, yeah, and that should basically be that one. You just put the percentage in for that you want to get, the target percentage, put it in there, and then solve the equation for the flow rate. And then once you get the flow rate by itself, you got your answer. So that is going to do it for 2.1.